So number 34 in the PPB is a similar question with a kind of an important distinction, which is to say that the lighting scenario here is not great. Sorry about that. So for number 34, we have a different box. This time the box is given to be 5 kilograms in mass, and that's being pulled to the right with a given force of 20 newtons. We'll call that F external. And that is, the whole system is sliding to the right against friction with a known acceleration A of 2 meters per second squared. So what else are we given? We are given, like I said, the mass, which is going to allow us to say that the weight is 5 kilograms times 10 is 50 newtons. From there, we can deduce that the normal is also 50 newtons. And then the question is, well, what is the coefficient of friction? And so there's a little bit of deduction that needs to happen here, because as you read the problem, you might recognize that we don't know the force of friction. So how could we possibly find the coefficient of friction, which from number 33, you remember, is the ratio of the amount of friction that you have for a certain amount of normal, F over N. So the question is, where are we going to get the force of friction to divide by the 50 newtons of normal? And the answer is we're going to get it by a sort of smart application of Newton's second law, which is to say that if we look at the equilibrium here in the horizontal axis, we'll see that actually we don't have equilibrium. We have imbalance. Because why? How do we know that? We know that because there's actual acceleration to the right. Okay, so the second law tells us that the sum of the forces is mass times acceleration. The sum of the forces is the external force minus the friction. And it turns out that we know the external force, and we actually can calculate MA and solve for the force of friction. So we had to write our own little equation to get the force of friction. So we would say 20 newtons minus the unknown force is equal to the mass, 5 kilograms, times 2, the acceleration, meters per second squared. So from there, we can solve this equation. It's 20 newtons minus 10 newtons is 10 newtons. So the force of friction is 10. If we plug that back into here, our definition of mu, we get 1 over 5, or 0.2, coefficient of kinetic or sliding friction.